Hi, welcome back to Imperium Learning. The topic of this video will be how to estimate and interpret an EGARCH 1.1 model on Eviews. Now, just to give you a brief introduction, it's an asymmetric GARCH model. That means it allows for the variance to react differently depending on the sign or the size of the shock that it receives. And again, the key distinguishing characteristic that separates this kind of model from other kinds of arch and GARCH models is its conditional variance equation. So just going on to the next slide here. Now, as you can see, this conditional variance equation looks a lot more complicated than the other arch or GARCH models. Don't worry about that. It's still pretty straightforward, particularly to interpret in a practical sense. All you have to know is that this is your constant, this is your GARCH term, this is our EGARCH term. So in particular, we're going to be looking at the sign and the statistical significance of this gamma, and finally this is our arch term. Now, bear in mind, in stark contrast to the GJR GARCH model, in order for evidence of the leverage effect to be apparent, this actually has to be negative. The sign of this coefficient has to be negative in order for evidence of the leverage effect to be present. This is in stark contrast to the GJR GARCH model, where the sign of the this gamma coefficient has to be positive. So just bear in mind that when we estimate this EGARCH model, we should be looking for this to be have a negative sign, and also for it to be significant at the 5% level. So now I'm just gonna show you how to estimate an EGARCH model. All you have to do, you click on Quick, you click on Estimate Equation, you go to the Method drop-down box, you click on Arch, and now we're going up to here and we're clicking on EGARCH, like so. And that's it. We just leave it the way it is because we're estimating an EGARCH 1.1 model. So what do? We type in our dependent variable, which, like always, is returns, and our conditional mean equation is the same as it always is. It's the ARMA model that you've probably worked out from your previous steps. Again, if you're just seeing this video and you haven't seen the videos before that, I'd advise that you go and look at those first. I've got some very helpful tips on how to find the correct ARMA specification. Go to options, again, make sure that the optimization method is set to Eviews legacy, and then after that you just click on OK. So I just want to open this out. I've actually got the print screen of the estimation output box already. Now, the first thing I actually want to draw your attention to is that, in contrast to the other models, the variables of the conditional variance equation are a bit more difficult to interpret if you've never done this before. The reason being is because it's very vague and it just says C7, C8, C9 and C10. So what I've done is I've just prepared a little slide just telling you what each variable is. So C7 is just the constant. C7 is just the constant. This little Greek letter here. And then after that, C8 is the alpha term, which is here. That's the arch term right there. C9 is the term beginning with gamma. So as you can see here, this is our EGARCH term. This is the key term that we're looking for when we want to investigate the leverage effect. And finally, C10 is the GARCH term. Now don't ask me why it's set out like this. I don't know why it's set out like this. It just is. But just to be clear, I've just written a few bullet points here. You can pause the video just to make sure that you know what each term is giving you an insight into when you're looking at it. So just moving on then to the kinds of things you can discuss. Well, first of all, we can talk about the significance of the terms. We can talk about the significance of the arch term and the GARCH term in particular, that's C8 and C10. These are very significant at the 5% level. However, as you can see from my my estimation output, you can see that my p-value is 0.68. So just like the results of my GJR GARCH model, it doesn't appear that the returns of my chosen index fund exhibit the leverage effect. Certainly not at a statistically significant level, albeit you can say that you could make a weak argument for the presence of it. And again, mentioned the sign, it was negative, so that would have been an indicator of the leverage effect. But again, since the p-value is above 0.05, you can only make a very weak argument, if any, for presence of the leverage effect. And so, I've just written another paragraph about the signs of the terms. The coefficient for our arch term is positive, C8, and so that shows that there's a positive relationship between the past variance and the current variance in absolute value. And so that means that the bigger the magnitude of the shock to the variance, the higher the volatility. And so so I've just got that. If you just want to digest that, you can just pause the video there. And then finally, like I put in all my other videos, do your residual tests. So like I said, I'm not going to show you how to do the residual tests. In this video, I've shown them in multiple videos already, so if you haven't watched the other videos, go and look at one of the other videos about how I do these two residual tests, and how I calculate the optimal lag length for my arch test. And so I think that's pretty much it in terms of all the models that I'm going to be estimating for this video series. The last video that I'll be doing is how we actually compare all the different models that we've estimated and which one has the best predictive capabilities when trying to forecast the future volatility of the returns of a chosen asset or an index fund or whatever. So that's the last video that I'm going to be recording. I'm going to do that right now. And so I'm just going to wrap up here, and that should be that. So bye now.